Now we will study what is the trend of ionic size or what is ionic size in S block elements. Now we'll be studying ionic size. To understand ionic size, we first need to understand what the word here ionic means. To understand this, let us take an example only. If I take an example of lithium, let us suppose lithium has an atomic number of 3 and has electronic configuration 1s2 and 2s1. Here the last electron lies in s orbital, so it's an s block element. Now, if this one electron is removed, let us suppose if one electron is removed, in chemistry this is known as ionizing. That is, lithium turns out to become 1s2 only. That is, this one electron is removed, and as the one electron is removed, positive charge acquires on the atom. That is, lithium is now ionized. And if the electron is removed, it becomes an ionic element. This is known as what ionic element is. Before, lithium, let us suppose these 2 electrons lied here and 1 electron lied here. The size of lithium was large. But as the electron is removed, last shell does not exist. So lithium size come out to be this only, because this is lithium positive. Hence, we get to know the fact that the size of an ion of an element is always less than the size of its parent atom. So, if I check the size between lithium and lithium positive will be smaller and lithium size will be larger. Hence, this is what ion is. Now we'll be studying the ionic size concept in S block elements. Now S block, as we again know, has two groups, group 1 and group 2. Group 1 and group 2. To become ion for group 1, it has to lose at least one electron. That is only one electron, because it has outer electronic configuration of 2s1 or 3s1. So in general, it has outer electronic configuration of ns1. Similarly, for group to become ionic, it has to release 2 electrons. That is ns2. Now let us see. Lithium positive, sodium positive, K positive, rubidium positive, cesium positive, and francium positive. As everyone loses one electrons, their size decreases. But with respect to each other, the order will be same as it was of their parents atom. Rubidium positive, cesium positive, and francium positive. Hence, the ionic size order comes out to be same as that of their parent atom. Same goes with the concept of group 2 elements. So, we can write it in similar way, but instead of 1, here 2 electrons will be lost because their last valence shells has 2 electrons. So, to become an ion, they'll be becoming like beryllium 2 positive, because 2 electrons will be lost. Similarly, magnesium 2 positive, calcium 2 positive, strontium 2 positive, pale 2 positive. Strontium 2 positive, Radium 2 positive. Hence, the order comes out to be same as that of their parent atom. So this was ionic size trend for group 1 and group 2. Group 1 elements and group 2 elements ionic size trend.